Okay, let's talk about scientific notation. Suppose I have 380 as a number. Well, I can write that in a different way. I could write that as 38 times 10, or I could write that, may as well use equal signs here, or I could write that as 3.8 times 100. That seems right. Well, this is like 38 times 10 to the 1 power, and this is like 3.8 times 10 squared. Another way to write this might be 3.8 times 10 to the 2. Well, when we write numbers like this, we call this scientific notation. In scientific notation, you usually represent the first number as a decimal with just one number to the left of the decimal. And then you multiply it by 10 times the number of powers it needs to create the original number. So that's how we do scientific notation. Now, not only can you do scientific notation in that direction, you can go the other way. Suppose we had 0.38 as our number. What does this equal? In fact, let me go even further. Erase. Let me go 0.0038. So that's a pretty small decimal. It's the same thing as writing 0.038 times 1 over 10. So you take your calculator and do that, but it's like dividing 0.038 by 10. What ends up happening when you divide by tens is you just move the decimal point to the left one. So, which is the same as saying 0.38 times 1 over 100, which is the same as saying 3.8 times 1 over 1,000. Okay, so now you want to look back in your notes and think about this. What is 1 over 10? That's the same thing as 10 to the minus 1, right? Because that's 1 over 10 to the 1. And if this is 1 over 10 squared, this is 10 to the minus 2, and this is 10 to the minus 3. So we can do the same thing that we did above, make it look real similar. We could say this 0.0038 is just 3.8 times 10 to the minus 3. That's scientific notation for a decimal. Don't believe me? Put it in your calculator, see what you get. Now, converting back from scientific notation is really even easier. So, suppose you had minus 2 times 10 to the 5th. So that's scientific notation. That's like 2.0 times 10 to the 5th. What does this equal? Well, it doesn't matter there's a negative here. You're allowed to have negative numbers. So it equals minus 2. Now, what we need to do is we just need to count. Since this is a positive exponent, we need to count to the right 1, 2, 3, 4, 5. And then we're essentially moving the decimal point that many times to the right. So this equals minus 200,000. Same thing works the other direction. Suppose we have 8.1 times 10 to the minus 3. Well, we have 8.1. Oops, let me make some room for this. We have 8.1. So now we have to count in the opposite direction. We're going to count left now. 1, 2, 3. I'll put a 0 over here and then a decimal point, 0, 0, because it looks nicer. 0.0081. And looks matter. When you're writing reports, it's always nicer looking if you put a 0 before your decimal point. Oftentimes, when you represent numbers like this minus 200,000, sometimes you'll put in decimal points to help you understand what the number of accuracy, how accurate your result is. You're accurate out to two decimal points, for example. But in that case, initially your scientific notation probably should have been written like minus 2.00 times 10 to the 5th. So how do we use this scientific notation? Well, suppose we have two numbers written in scientific notation and we want to multiply them together. Well, remember, all this is just multiplication. It's like 8.1 times 10 cubed times 3.2 times 10 to the minus 2. We can mix all this up in the order that we solve it, since this is all multiplication. So we could solve 8.1 times 3.2 and then multiply that by 10 cubed times 10 to the minus 2. So if we multiply this out, I forgot to unpause, we have 8.1 times 3.2 times 10 cubed times 10 to the minus 2. I could mix these and match these up any way I want. I just grouping them like this because it looks nicer. So 8.1 times 3.2 is 25.92, and 10 cubed times 10 to the minus 2 is 10 to the 3 minus 2, which is 10 raised to the 1 power, times 25.92, which is 259.2. If we want to do this in a calculator, we'll go 8, I'll raise this up higher, 0.1. Now, different calculators are different. This one is the EXP. Notice this is scientific notation raised to the power of 3. Okay, so I'm going to multiply that. It actually worked that out automatically for me, times 3.2 raised to the power, I got to go with a negative, so this turns this into a negative now instead of a positive, 2, negative 2, and this equals, and so then it worked it all out, 259.2. So that's how you do it. So scientific notation is really just a simplification to your math life. So you should look at it as a good thing. All right, that's all I have to say here.